आजमगढ़ जनपद की प्रतिभाशाली बेटी प्रिया उपाध्याय पुत्री कृष्णकांत उपाध्याय निवासी उकरौड़ा हाफिजपुर ने अपने अद्भुत शोध कार्य से भारत का नाम अंतर्राष्ट्रीय स्तर पर रोशन किया है। प्रिया, जो वर्तमान में NIPGR JNU नई दिल्ली में रिसर्च साइंटिस्ट के रूप में कार्यरत हैं, ने लंदन स्थित यूनिवर्सिटी ऑफ लीड्स में आयोजित कार्यक्रम में भारत का प्रतिनिधित्व किया। यह अंतर्राष्ट्रीय सम्मेलन 21 अक्टूबर से 23 अक्टूबर 2025 तक आयोजित हुआ, जिसमें विश्व भर के प्रमुख वैज्ञानिकों ने भाग लिया। इस अवसर पर प्रिया उपाध्याय ने अपने अभिनव शोध विषय पर व्याख्यान प्रस्तुत किया। अपने शोध के माध्यम से प्रिया ने यह सिद्ध किया कि मूंगफली जैसी सामान्य फसल से भी अत्यधिक पौष्टिक प्लांट बेस्ड प्रोटीन तैयार किए जा सकते हैं, जो भविष्य में शाकाहारी भोजन का एक सशक्त एवं टिकाऊ विकल्प सिद्ध होंगे। यह शोध मानव स्वास्थ्य और खाद्य सुरक्षा के क्षेत्र में क्रांतिकारी परिवर्तन ला सकता है। प्रिया उपाध्याय को इससे पहले 9 नवंबर 2024 को नई दिल्ली में उनके उत्कृष्ट वैज्ञानिक योगदान के लिए राष्ट्रीय सम्मान से नवाजा गया था। यह सम्मान भारत सरकार के नीति आयोग के पूर्व CEO अमिताभ कांत सहित देश के प्रख्यात वैज्ञानिकों द्वारा प्रदान किया गया। उनके अनुसंधान कार्य की उत्कृष्टता को देखते हुए प्रिया को JRF के साथ साथ राष्ट्रीय स्तर पर फंडिंग भी स्वीकृत की गई है। प्रिया ने अपने एक अन्य शोध कार्य के लिए गोवा में आयोजित 13वीं अंतर्राष्ट्रीय बायोटेक्नोलॉजी कॉन्फ्रेंसेस में हिस्सा लिया था, जहां उन्हें बेस्ट पोस्टर अवार्ड से सम्मानित किया गया। इस उपलब्धि ने न केवल विश्वविद्यालय बल्कि पूरे जनपद आजमगढ़ का गौरव बढ़ाया है। उनकी यह सफलता आने वाली पीढ़ियों की बेटियों के लिए प्रेरणा बनेगी।
Then it not should be a compromise. Like animal, we eat golgappa. Why? Because the flavor we like, we want that flavor. That's why we are eating golgappa. So same idea is here also. If animal meat, they want to like quit animal meat eating, but they have to compromise by eating plant meat. So our idea is that this should not be a compromise. If they are eating plant meat, they should get that exact flavor, aroma and texture of animal meat. And also while cooking also they get that same feeling that they are cooking animal meat itself, but it is derived from plant. That is the idea.
But vegetarian population will never use this because they will feel that it is some kind of blood, etc. and all that. I am
also a vegetarian. So I don't think it is like that.
Okay.
I'm also
good. No, I'm glad that you are very confident. Great.
So this is the idea which came in our mind, and in US, New Zealand, Singapore, they are already using it. So we can also.
Hello everyone. Myself Priya, a PhD student at NIPGR. Welcome to the innovative journey of how the evolution happened in peanut when we talk about globins. So as you can see here, we all somewhere heard about a symbiotic interaction. So plant bacteria interact, in turn this nodule formation happens. So inside this nodule, the nitrogen fixation happens with the help of this bacterial enzyme which is nitrogenase. But this nitrogenase is an oxygen labile enzyme. So plant have to maintain a minimum oxygen concentration inside this nodule so that this nitrogenase can work efficiently. That is why plant express lead hemoglobin inside the plant nodule, similar to our blood, as we have hemoglobin and it transports oxygen to our blood. So this lead hemoglobin sends the oxygen, it binds to the oxygen and maintain a minimum oxygen here inside the nodule so that this nitrogenase, which is a nitrogen fixation machinery, it can work efficiently. But this lead hemoglobin has to maintain a specific structure so that this oxygen can bind easily and dissociate easily because it has to maintain a minimum oxygen inside the nodule. That is why this lead hemoglobin is always in a penta-coordinated structure so that it can transport oxygen to the bacteria so that they can respire, and also it can maintain a minimum oxygen inside the nodule so that this nitrogenase can work. So what about peanut globin? Is it the same hexacoordinate or pentacoordinate structure? So in the RNA-seq, what we have found that there is no leg hemoglobin genes in peanut. Further, when we did this phylogenetic analysis, we found there are 5 globin genes in peanut which cluster with class 1 non-symbiotic globin. So here a parallel evolution has been happened, like this leg hemoglobin has been evolved from dimeric hexacoordinated structure to a monomeric pentacoordinated structure. But in peanut, what we have found, this hemoglobin has been evolved from class 1 non-symbiotic globin, which is a dimeric structure as well as hexacoordinated structure. So as it is nodule specific, so we have designated it a name, that is symbiotic hemoglobin in peanut. So what we have found in peanut, I purified this protein symbiotic hemoglobin and found a characteristic solid spectra which confirms the heme group present in peanut globin. Further, what I have found on reducing this protein, it is showing a characteristic Q spectra which confirms that it is a hexacoordinate globin. In the side exclusion chromatography, I have found this peanut symbiotic hemoglobin came out to be a monomeric protein and hexacoordinated structure. So the question arises, it is behaving the same as leg hemoglobin. So we have got these seeds, Lotus japonicus CRISPR lines, they have deleted all leg hemoglobin genes. I have complemented these lines with Lotus leg hemoglobin itself and peanut symbiotic hemoglobin itself, and I found that yes, peanut symbiotic hemoglobin is doing the same function as the leg hemoglobin. Further, I have to validate this experiment by doing kinetics experiment as well to show that whether the oxygen binding and dissociation affinity is same or not. Further, in the synteny analysis, I found this peanut symbiotic hemoglobin have evolved from this non-symbiotic globin 1. So I have purified this protein, did this spectra analysis and found that this non-symbiotic hemoglobin, when I have oxidized, its conformation changes fully. And also it came out to be a dimeric protein. So the question arises, how this evolution has been happened from the dimeric non-symbiotic globin genes to the monomeric symbiotic hemoglobin genes. So my future plans are further to study how this evolution has been happened by mutating the conserved dimeric interfaces of this non-symbiotic globin so as to trace the evolutionary pathway of globin in peanut. At last, I would like to thank my supervisor Dr. Sinjyoti Sinha Roy for all the guidance, my organization NIPGR, UGC for the funding and my DBT Institute for all those funding related things. Thank you.
Thank you, Priya. Very good energy and well in time. So I request Dr. Madhvi Sharma. She will